All right, so let's talk about the remainder theorem. So the general formula for the remainder theorem is given by, say, you have a function f of x that will be equal to x minus a multiplied by the quotient q of x plus the remainder. Now, you know that whenever you are, say, doing the long division of polynomials, you'll have your quotient q of x, and you'll be dividing that by your divisor, which is usually x minus a. Now, the remainder theorem states that whenever you substitute or find f of a, then you'll find the remainder of your function, right? Whenever you do the long division of the polynomial. Now, whenever you're looking at math in general, many students often neglect the fact that we have signs in front of these variables and even real numbers. You can't do that because here the sign is telling you that this term here is actually negative a. And so here the importance is they're telling you that you should substitute a, which is actually a positive a. Now, here, that means that we've actually multiplied that negative a by negative 1 in order to get that positive a, which we'll substitute, right? So, in a sense, they'll tell you to flip the sign whenever you are substituting a into your function for x. When we substitute positive a or whatever a it's going to be this time, I'll use real numbers so you can get this into a bit of perspective. But for now, we're going to substitute positive a. So you have the same function and we're finding f of a, all right? So wherever you have x in your function, we'll put a. So a minus a multiplied by q of a plus r. A minus a is actually equal to 0. So we'll end up multiplying 0 by q of a. And let's just put plus r for now. Anything multiplied by 0 is actually equal to 0. So it doesn't matter what the quotient is. As long as we multiply it by 0, you'll still get 0. And if we add r, then we'll find that the function f of a, right, is indeed equal to r, which is our remainder. So if we substitute a into our equation, then we'll find the remainder. Let's take this function for example. F of x is equal to 3x cubed plus 2x squared plus 4x minus 3, and our divisor will be x plus 2. All right, so I'm going to show you with the remainder theorem first, and then I'm going to go through the process of long division to prove to you that the remainder theorem is actually true. So here, if this is written as x minus a, right, or this is our x minus a value, or divisor right here, x plus 2, then that means that the a value that we should substitute would be minus 1 multiplied by that positive 2 that we have here, right here. So for our a value, we'll substitute negative 2. So in this case, we're finding f of negative 2. So that would be 3 times negative 2 cubed plus 2 times negative 2 squared plus 4 times negative 2 minus 3. Okay. All right. So if you go ahead and actually start working this out, you can take it step by step. 2 cubed or negative 2 cubed would be negative 8 because negative 2 times negative 2 is positive 4. And positive 4 multiplied by negative 2 would be 4 2's 8 and it's negative 8. Okay. So then we'll have negative 8 multiplied by 3 and 3 8's 24. So that's negative 24. And negative 2 squared is positive 4 multiplied by another 2. That's positive 8. And negative 2 times 4, that's minus 8. So 4 2's 8. So we'll end up doing that anyways. Then minus 3. We can go even further, simplifying it. So plus 8 minus 8 would actually cancel each other out because that would be equal to 0. It's 8 minus 8. Then you have negative 24 minus 3. That would be equal to negative 27. Good. So you could even put that in your calculator and you're supposed to get the same answer. Now, if I do the long division, where 3x cubed plus 2x squared plus 4x minus 3 is our quotient. And of course, we're dividing by x plus 2 as stated earlier. We'll go ahead and divide, right? So x into 3x cubed, that's 3x squared. 3x squared multiplied by x is 3x cubed. And 3x squared multiplied by 2, that's positive 6x squared. And so if we subtract 3x cubed minus 3x cubed, that's 0. But 2x squared minus 6x squared, that is negative 4. Very good. 4x squared. And bring down the 4x here. So plus 4x. We'll do the same thing. So x into negative 4x squared, dividing a negative by a positive. So of course your result is going to be negative. And that's going to be 4x. We'll cancel one of the x's. So negative 4x multiplied by x is negative 4x squared. And negative 4 times 2. 2 4 is 8. That's minus 8x. We'll go ahead and subtract again. So negative 4x squared minus negative 4x squared. It's actually going to become plus, so they'll cancel each other out. And 4x minus negative 8x is going to actually become 8 plus 4, right? So that is nice, 12x. And we'll have to bring down that negative 3 at the end. Do the same thing. X into 12x is a positive 12. And 12 times x is 12x. And 12 times 2 minus 24. Well, positive 24, rather. And again, subtract. So 12x minus 12x cancels each other out. So that's 0. And negative 3 minus 24 is negative 27. So doing the long division, we also got negative 27 as our remainder. All right, so try this one on your own. Using the remainder theorem, what would be the remainder of a function f of x, say 2x cubed plus 3x squared plus 4x plus 2. And let's say our divisor is x plus 3. So pause the video, try to evaluate it yourself. All right, so first multiply that a value by negative 1. So that's negative 3. So we'll be substituting negative 3, right? So f of -3 is what we'll be evaluating. So that's 2 times -3 cubed plus 3 times -3 squared plus 4 times -3 plus 2. So f of -3 would be equal to, do you want to go the long route? So -3 cubed, that's equal to -27 and multiplied by 2. That would be -54, right? Plus -3 squared is +9, and +9 times 3, that's 27. Then -3 times 4, that's -12 plus 2, right? So now let's say you have -54, right? Plus 27. That would actually be 27 minus 54, which is 27. We keep the sign of the larger number, so that's -27 minus 12, because this negative sign essentially cancels this positive sign out, plus 2. So -27 minus 12, you'll add 27 and 12 and keep the negative sign. So that's -39, then plus 2. And -39 plus 2 would be 39 minus 2, and of course keep the sign of the larger number. So that would be -37. So that means the remainder R, sometimes written as R of X, is equal to -37. Nice, right? Simple enough. All right, so let's try some harder practice problems. Okay, so this says when the polynomial f of x being equal to 2x cubed plus 3x squared plus ax plus 2 is divided by x minus 1, the remainder is 8. Find the value of a. Try it and then see what I do, okay? So based on this, we know that f of +1 would be equal to 8, because again, this is our divisor and we have to multiply that a value by -1. -1 multiplied by -1 is +1. And they told us that the remainder is 8. So we know that whenever we substitute +1 into this equation, we would get 8 as our final answer. So in that case, we can actually expand this and write 2 times 1 cubed plus 3 times 1 squared plus a times 1, because we don't know the value of a just yet, plus 2 is all equal to 8, right? Then simplify. So 1 cubed is 1, and multiply that by 2, that's 2, plus 1 squared is 1, multiplied by 3, that's 3. 1 times a is simply a, and we have a plus 2 at the end. 3 plus 2 is 5, plus another 2, that's 7, yeah? So 7 plus a is equal to 8. Finally, we need to get this 7 over here, simply to get the equation being read as a is equal to something. So since this is a +7, to get it on the other side, we have to do the opposite operation, which is subtracting. So 7 minus 7, that's equal to 0. So that would be 0 plus a is equal to 8 minus 7 as well, because in order to keep the equation equal, you have to do the same thing on the other side. So a, therefore, is equal to +1. And essentially, you're done with that question. All right, let's talk about what we do if you're required to find the values of two variables, right? So A and B. whenever you have to find two variables, just instantly think that you need a simultaneous equation. So let's see. When a cubic polynomial f of x being equal to x cubed plus ax squared plus bx plus 3 is divided by x minus 2, the remainder is 7. And when it's divided by x minus 3, the remainder is 15. So here we have minus 2, and if we multiply that by negative 1, that's a positive 2. So we'd be finding f of positive 2. And for the negative 3 here, we'd be finding f of positive 3, because negative 1 multiplied by negative 3 is equal to positive 3. So we know that f of positive 2 is equal to 7. And also f of positive 3 is equal to 15. So we can go ahead and do some substitutions and figure out our two equations. So first, f of 2 would be 2 cubed plus a times 2 squared plus b times 2 plus 3 is equal to 7. And we'd have to simplify that, right? So 2 times 2 times 2, that's 8. And 2 times 2 is 4 for A. Then 2B, because 2 times B is 2B. And 3, and that's equal to 7. We can go ahead, 8 plus 3, that's 11, yeah? Plus 4A plus 2B is equal to 7. And of course, to get this 11 on this side of the equation, well, that was a bit short, but over here, we'll have to subtract 11 from both sides. So 11 minus 11 plus 4A plus 2B is equal to 7 minus 11. So 4A plus 2B is equal to negative 4. All right. Now, for f of 3, it's essentially the same. So let me see if I can get it under here. So 3 cubed plus a times 3 squared plus b times 3 plus 3 is equal to 15 this time though. So 3 cubed is 27. 3 3 is 9, and 9 times a is 9a. 3b plus 3, that's equal to 15. So 27 plus 3, that's 30. Plus 9a plus 3b is equal to 15. So essentially, we'll have to subtract again 30 from both sides. So 9a plus 3b will be equal to 15 minus 30. 15 minus 30. And 15 minus 30 is negative 15. So this is our second equation. So this is our first. And right here, we've got to our second equation. All right, so now we have our simultaneous or two equations. So we'll work out a simultaneous equation. So let's call this equation 1 and this equation 2. Now, it doesn't really matter what method you prefer to work out simultaneous equations. I prefer the substitution method. So we're going to go ahead with that. So let's say I take this and I make A the subject. So 4A plus 2B is equal to minus 4. And I'm trying to make A the subject. So I'll bring this 2B over first. So that would be 4A being equal to negative 4 minus 2B. And of course, I'll have to divide by 4 on both sides. So A would be equal to essentially negative 4 over 4 minus 2b over 4, right? Because you can split it. Remember, that's how we do normal fractions. If you're adding a half and a half, because the denominator is the same, it would be 2, 1 plus 1 over a single 2. Yeah, because we keep the denominator. So canceling that would be negative 1 minus 22, 1, 24, 2, b over 2, or half b, right? It's the same thing. So that's what A is equal to. So I'll take equation 2, 9, and because A is equal to minus 1 minus b over 2, I'll put that there, plus 3b is equal to negative 15, and we'll work from there. So distribute the brackets. So 9 times negative 1 is negative 9. 9 times negative b over 2 is minus 9b over 2. And if I add that to 3b, that's equal to negative 15. So we can go a bit further and do simplify negative 9 and positive, well, that's a 3b. I thought that was 36. All right, so we can go ahead and bring over this negative 9, right? So minus 9b over 2 plus 3b is equal to negative 15. Now, if we're going to bring it over, we have to change the sign, so plus 9. And so if we simplify it, it's minus 9b rather, over 2 plus 3b. I'll write it as 3b over 1. And that's equal to minus 15, right? Plus 9. So remember, to do this, you would subtract 9 from 15 and keep the sign of the larger number, which is 15. So negative 15 plus 9 is equal to negative 6. All right, not bad, right? Now, to make this easier, I'll multiply this entire fraction by 2 to make it the denominator is the same, right? So I want the whole thing to be equivalent. Well, let's say multiply by 2 over 2. So 2 times 3b, let's just write back this minus 9b over 2, plus 2 times 3b would be 6b over 2, because 2 ones 2. So now we have negative 9, right? Plus 6, which is literally 6 minus 9, and we'll keep the sign of that, the negative 9 here. So that's going to be, I'll write it over here. That's going to be negative 3b, right? Over 2. And remember, we had an equal to negative 6, right? So let's multiply by 2 on both sides to get rid of the 2 in the denominator. And that will give you negative 3b being equal to negative 6 times 2 is 12. So divide by negative 3 on both sides. And you'll find that b is equal to positive 4. Great. Then, since we found that b is equal to positive 4, let me clean this so that I can get a bit more space. All right, so now that we found that b is equal to 4, we can use either equation 1 or equation 2 to solve for a. It doesn't really matter which one you choose. So I'll choose equation 1. So for a plus 2b is equal to 4, is equal to negative 4. So 4a plus 2 times 4 is 8 is equal to negative 4. Then 4a plus 8 minus 8 is equal to 4 minus 8. Because we wanted to get this 8 over here. So we need to take it away from this side so it cancels out to 0. And remember, in order to keep an equation equal, you need to do the same thing on the other side. So 4a is equal to negative 12, yeah? 4 plus 8 is 12. So divide by 4 on both sides to get rid of that 4. So we can get a is equal to negative 3. So the value of a is negative 3 and the value of b is 4.